23. It's found in your book on page 166. This is Algebra 3. It's talking about the exponential function and sketching exponentials. A lot of this just kind of comes down to, it does give you some hints about how to do things, but for the most part, your graphing calculator is going to end up doing a lot of this heavy lifting for you. They start off here with a question here. If we have y equals 1/2 to the x, that x being an exponent. So if we look at that as to the negative third, right, we would ultimately want to drop that below the division bar. So we would get y equals, in this case, 1/1/2 to the x, right, at least in the negative instances. All right, so if that's the case and we plug in, now that becomes a 3 here. All right, so 1/2 cubed is going to be 1/8, right? But it's 1/1/8, right? Yes, which means I have 1/1 divided by 1/8, which means I multiply by the reciprocal, right? And I get 8/1, correct? All right, so for where x equals -3, I actually get an 8 there. All right, for the instance where it's 2, right? Well, 2 squared is going to be 4, so what's going to end up changing in here is that this becomes a 4, correct? Because I'm squaring it, so this answer is 4. Okay? And if I'm taking it to the first, really nothing's changing. I'm just getting 1/2. So this number stays a 2, which means my answer is 2, right? If it's 0, I'm taking something to the 0 power. What happens when I take something to the 0 power? I get 1, so I have 1 divided by 1, which is 1. All right, so you notice that as my x values are increasing, my y values are decreasing. Okay, so I have somewhat of, it's not an inverse variation, at least not straight across. But then if I go to plug in 1, now I have 1 divided by 1/2 again, right? Actually, I'm sorry, now it's just 1/2 to the first, right? I don't need that second equation. It's just 1/2 to the first. So it continues to go down where this answer is just 1/2, okay? Now, if we go to 2, right, I'm getting 1/4. 1/4 and then 1/8. So you see actually that I go 8, 4, 2, 1, and now I get these 8 4s and 2s as the denominators of the fractions as I go on. So it goes 1/2, 1/4, 1/8, where it was 8, 4, and 2, right? Okay, so we can do that. Is there anything wrong with the math there? Could we have done all of that? The only thing that I'm uncertain that you might have seen is that if I'm taking 1/2 to a negative exponent, I'm actually got to drop it below the division bar, get a positive exponent, solve from there, right? Okay, so let's see what happens if we plug this in our graphing calculator. Do we get the same table of values? Okay, if we did it right, hopefully. All right, so we're going to go to y equals, clear out what's already there, if anything. 1 divided by 2, caret x. Okay? Now, I'm less interested in the graph for now as I am the table. So I'm going to hit second graph and get myself a table of values and go up to -3. Okay? 8, 4, 2, 1, 1/2, 1/4, 1/8. Does that make sense? Okay, let's check our graph out, see what that's going to look like. And it matches what it should, which is exponential decrease function, correct? Okay, so any problems with any of this so far? Okay, here we're making a table of values. We're just sketching 4 to the x, so it's an exponent. So because it's not a fraction to an exponent, I should be getting exponential increase, correct? Because if I've got x to the first, right, 4 to the first, I should get 4 squared, 16, 64. Notice on the opposite side it goes 4, 1/16, 1/64, so on. What are we laughing at, guys? All right? Okay. All right, so we should be getting an exponential increase. We'll go ahead and check 4 to the x, graph, find an exponential increase, second table, and we can go ahead and fill in our table. Okay, so -3. You may not know what those decimals are right off the bat, so I would go ahead and test, okay, is 1/64 0.1563? If it is, then that matches. Okay, 1/16, 1/4. A should be my answer on these. Okay, or at least on that question. Okay. 3, same thing. Graph, it's going to be an exponential increase. We go on to the next portion here. If I've got a fraction to an exponent, it's going to be exponential decrease. We saw that with question number 1. Okay, it's just going to change a little bit. And then on 5, what you want to be careful with if you plug in number 5 into a graphing calculator is that if you deal with an older calculator with like the emulator that I have here, okay, be careful that you list your entire exponent in parentheses. So I got 1 divided by 2, caret parentheses, because the whole thing is an exponent. If I don't, I'm going to take it to the x, and then I'm going to subtract the entire function. I'm going to subtract 6 from the entire function, rather than taking the entire function to the value of x minus 6. Right, so that I get this. But it'll probably still be an exponential decrease. It's just moved to the right. Okay, does anybody have any questions, concerns about anything from this so far? Okay, that's it as far as that lesson goes. Are we good there? We see how our calculator is going to do a lot of that. So the question should come up, okay, if I see a question like this show up on a test, what kind of work do I need to show? Right? I want a table of values. Okay, give me the table of values, and then you can give me a sketch of the graph. Okay? All right. So from here, let's go to lesson 24. Okay, it's this guy right here. All right, this does involve quite a bit more work. Let's go over, this is picking up on page, in our textbooks anyway, page 172, sum of trigonomic functions and combining functions. Okay, so we're going to use reference triangles to solve these. Okay. And let's see, if I have my sheet in front of me, I'll end up just flipping to another page. Let me see if I can find 24, 3 radical 2 over 5. Looks good. All right, so what I'm going to do is I'm going to work these out on a separate page. Okay, we have 3 radical 2 over 5 cosine 45 degrees. Well, let's start with that. Okay. Well, cosine 45 degrees tells me I'm going to have a 45, 45, 90 triangle, right? And we're just going to use those to ratio, so it should be 1, 1, radical 2, correct? Now from there, we're going to look at one of our 45-degree angles. Let's pick this one right here, and we're going to come up with the ratio that we would need. All right? Cosine is what, class? This is taking us way too long. If we don't know this by now, we're really going to struggle with this. No, it's not. Adjacent over hypotenuse. So, S-O-H, sine. Ca, C-A-H. Adjacent over hypotenuse. Adjacent here to that angle is what? 1. What's hypotenuse? All right, so what we have is we have 3 radical 2 over 5 times 1 over radical 2. Okay, so you have 2 options. Either we can go ahead and rationalize the denominator of 1 over radical 2 now, or we can do it after we multiply. I prefer to do it before, so we'd multiply by radical 2 over radical 2, right? What's that give me on top? Radical 2, right, over what? 2. Does everybody get and understand that? All right, now as I multiply across, all right, what's 3 radical 2 times radical 2? 3 times 2 is 6. 5 times 2 is 10. Okay, we could reduce that. We could get 3/5, right? Okay. All right, just in case we need it. All right, let's come back up because we're going to do these one part at a time. Okay, then it says plus 3 radical 3 over 5 cosine 30 degrees, right? Okay. So yeah, 30, 60, 90, 30, 60, 90. We want the cosine from the 30. So this one matters a little more. What goes opposite of 1? Or sorry, 30? 1. What's my hypotenuse? 2. What's opposite 60? Radical 3. So if you don't know these yet, you need to write them down, memorize them, get them in your head, right? Put them on a cue card, study them before you go to sleep at night, because you're going to need this for the rest of the year. If you do not know your special right triangle ratios, you will struggle, okay? You need to make a list of stuff that you don't know that you need to work on, okay? There's not very much hand-holding in this class. All right, 3, radical 3. I'll help you where I can, okay? Cosine. Cosine is what? All right, what is adjacent to the 30-degree angle? Adjacent. Radical 3. Okay, what is hypotenuse? All right, did I hear somebody struggling to know what's opposite and adjacent? Okay. If we can identify opposite and we can identify hypotenuse, the adjacent's the only thing that's left. Okay? Okay. So we need 3 radical 3 times radical 3, which is what? 9, because radical 3 times radical 3 is 3. 3 times 3 is 9 over 10, right? Which is giving me, what, 3/5? Oh, hold on. Can't do anything. Can't do anything with that, right? It's just 9/10. All right, so 9/10. Sorry about that. All right, and then we have one more. Minus 4 radical 3 over 5 tangent 60 degrees. Okay? So, I mean, I could even go back and just use that guy right there, couldn't I? I don't need to redo it. Okay, but this time we want tangent of 60. Okay, well, what is tangent? Opposite over adjacent. What is opposite to 60? Radical 3. All right, so we've got negative 4 radical 3 over 5 times, you said radical 3 over adjacent. 1. Okay, good. All right, so as we pull this down, what's negative 4 radical 3 times radical 3? Negative 12 over 5. Okay? So we have 3/5 plus 9/10 minus 12/5. All right, I'm going to have to get everything into a common denominator, which would be tenths. So 6/10 plus 9/10 minus 24/10. Okay, we know we're going to get our answer into tenths. 9 plus 6 is 15. 15 minus 24, negative 9. Negative 9/10 is my answer. Is there a lot of steps? Yes. Is there anything too hard for us to do there? No. Okay. Okay, let's look at our next one. It says draw a reference triangle. Let's see. For sake of time, do we feel like we understand that well enough to move on from it? Yes. Does anybody want to do number 2? Okay, well, I know that you two don't speak for everybody. Does anybody want to see number 2? Okay, if you need help with it, come find me. All right, we're going to move on. And the answer for number 2 is C. Okay, so if you work that out on your own and you can't get it, then come to me, okay? All right, number 3. Okay, number 3, I've got x minus 9 over x. This is f of x. Okay? We know that g of x equals x squared minus 1. We want to know g of f of 7. Okay, g of f of 7. Well, we can do it either way, but when we say G of, what we mean is that F going into G, or is G going into F? F is going into G, because it's the same thing as if we see G of F of, and in this case it's 7. So G is on the outside, right? That's the big thing. I call these Russian nesting doll questions. Your question is, what is the big Russian nesting doll and what's going inside of it, and then if possible, what's going inside of that. So if I'm solving this algebraically, the way that I'm looking at this is, here's my big parentheses, squared minus 1. Now I've got to fit F into it, so I'm doing x minus 9 over x. And because we're actually plugging something in, we're getting 7 minus 9 over 7 squared minus 1. Does that make sense? So when we're plugging something in, we're finding that x, and we're making a big set of parentheses, and we're putting everything inside of it. Okay? So now we just simplify. So 7 minus 9 is? So I've got negative 2 sevenths squared minus 1. Well, what's negative 2 times negative 2? 4. Okay. 49ths. 4 49ths minus 1. Okay, that would be the same as minus 49 49ths. Correct? Negative 45 49ths. Okay? And what I want you to see is that you're not always going to get an answer that's like 7 or negative 2, right? Some nice, neat fraction like 1/2 or 2/3, right? Sometimes you get something that looks kind of ugly like negative 45 49ths, right? We're kind of past the point in our mathematical career where everything's going to come out to something that, okay, well, that just, it looks like an answer I would get, okay? All right, number 4. It says if cosine theta, if f of theta equals cosine theta and g of theta equals sine theta, find f of 90 degrees and g of 330 degrees. Do not use a calculator. Well, we won't. All right, so listen. We are going to substitute cosine theta in for f. So we're saying cosine of 90 degrees. We're rewriting it. Does that make sense? Do we see what's happening? Okay. All right. Plus what? Sine of 330 degrees. Because they're giving me degrees, I'm going to look at this. All right. Well, 90 degrees shows up where? The y, or the y-axis, correct? All right. Cosine refers to what axis? The x-axis or the y-axis? The x-axis. So what is the cosine value at 90 degrees? What is the cosine value at 90 degrees? What is the x value at 90 degrees? 0. And you can type it in your calculator. Cosine 90, cosine 90 equals 0. Right? We can test that. Do we understand it though? Because if I understand it, I can get to 0 before you can get to 0. Right? All right, sine of 330. All right, well, 330 is going to be down here, right? What's the reference angle? What's this angle right here?
360 minus 330. 50. Yes. No, 360 minus 330 is 30. 30. No, that's 280. Yes, I couldn't get it out.
I'm glad you're not loud enough to come up on the recording. Okay, so what's opposite of 30? 1. What's opposite of 60? What's my hypotenuse? 2. Okay, what's missing? What did I not do that I should have done? But you guys didn't say it, so. What's opposite of 30? Anybody see their mistake? Where am I? Look at where you are on the coordinate plane. Has to be a -1 because I'm below the x-axis, okay? Now, we're at 30 degrees, right? So that's the angle that I'm using. What is sine? Okay, opposite over hypotenuse. What's opposite of my angle? -1. What's hypotenuse? Okay, so 0 plus -1/2. My answer is? Okay. Can you plug it in your calculator and get an answer? In this case, you can. But if my answer comes out to a radical, which is possible, right? Radical 3 is up there, right? My answer could have come out as a radical, right? So do I need to know how to do this pencil paper? Yes, you have to know how to do a pencil paper. Okay? All right. Let's look at another one. This says F times G, sorry. Yeah, F, G, 3. Okay? So yeah, you can solve this algebraic or numerically. So F is x minus 1. G is x squared minus 2x plus 2. All right, so solving algebraically, I would go ahead and FOIL that through, and after I've done it and simplified it as far as I can get, I would plug 3 into it. Solving numerically, I would do 3 minus 1 times 3 squared minus 2 times 3 plus 2. Which do you think might be easier in this case? Numerically or algebraically? Numerically, 3 minus 1 is 2. What's 3 squared? 9 minus 6 plus 2. Okay. Let's see, what's... okay, 9 minus 6 is 3. 3 plus 2 is 5. My answer is 10. Okay. All right, so numerically tends to be easier. It's not always. Okay. Let's see. Which one, 6 or 7? You're looking at 7. Do you guys need me to work out 6 with you? No or yes? Nobody said yes. So number 7, you guys want to see number 7? Number 7 is not hard. It's just all of the things that you could do. Okay? It wants to know what f plus g of x is, f minus g of x. Find f of 2, find g of 2, find f plus g of 2. Right? It's just having you do it a number of different ways in time. So f plus g of x, all right, where this is what we're getting. We're getting for number, that first part is x squared plus x plus 2 plus my g plus, which is, I'm going to rewrite this. So I got 3x squared minus 2x minus 4. I want you to add those up. Okay, just algebraically. All right, so I'm getting, what, 4x squared minus x minus 2, right? All right, so that's the answer for the first part, correct? All right, 2 wants f of 2, right? So that's 2 squared plus 2 plus 2, right? So what's your answer? Hold on. Did we, oh, we missed one part, didn't we? We missed the minus, correct? X squared plus x plus 2 minus what? Minus 3x squared plus 2x plus 4. Why was it different? You distribute the negative. Okay? So instead of that, what am I getting here? I'm getting negative 2x squared, correct? Because negative 3 minus, or negative 3 plus 1 plus 3x plus 6. Okay? Then on the next one, right, it wants f of 2, right? So 2 squared plus 2 plus 2 equals what? 8. Okay? You all right?
Yeah.
Okay, 4. What did 4 want? Fourth part. What a g of 2, right? So that's negative 4 minus 2 times 2 plus 3 times 2 squared. Well, 2 squared first, right? It's 4, so I've got 3 times 4, 12. I've got negative 2 times 2 is negative 4. So I've got 12 minus 4. I got 12 minus 8, right? What's 12 minus 8? Okay, I get 4 for an answer here. I had 8 up here. Finally, the fifth part wants to know what f plus g of 2 is. Well, if f of 2 is 8 and g of 2 is 4, that's already been done, and it wants me to add those together. It's 8 plus 4. Okay? Now, I do want to do number 8 before we close out, okay, because I've not done a lot of these Russian nesting doll situations, but it tells me that f of x is x plus 1 over x, g of x is x squared plus 7. It wants to know g of f of 2, okay? G of f of 2. It helps me to write it that way. That way I know what's on the outside. Because if I read it, I'm thinking g of f, I'm thinking that g goes into f, but that's not how it works. Okay, so we start with g. G is x squared plus 7, right? All right, so tell me what to write here. See if you guys know how to do this. Parentheses, big parentheses, okay? Okay, so I need another set of parentheses, right? Okay, square it plus 7. Okay, what goes inside that parentheses? X plus 1 over x. Okay, what am I doing? Am I doing anything else? Really, because it is in a situation where I am plugging something in for x, right? I'm going to leave parentheses there and plug in what? 2. All right, so 2 plus 1 is, so I got 3 halves squared plus 7. Okay, what is 3 halves squared? Somebody besides David? 9 fourths. Okay, plus 7.
37.
Okay, well, let's see, be what, 29 fourths plus 28 fourths? Is that right? Okay, and you said that was 37 fourths? And that is B, I think, on your answer sheet. Okay, any questions about anything from 23 or 24? No, we feel pretty good about all of that? Maybe? Is there a question anybody wants me to go back and cover that we didn't cover? We didn't do that number 2. Does anybody need to see where we had to draw the reference triangles and all of that, or we had a 30, 60, 90, 45, 45, 90, see how we multiply those ratios, add them all up? No? We're good? Okay. Stop there.